Hey guys, happy Wednesday. It is Mr. Ellis, your algebra teacher. Just making this video to go over the problems for week 3, the math problems. So let's just get started. All right, 4, 6. In the Marquez reading, I know I had the Marquez reading, but at the bottom here, if we look at the assignment, it does say, look at the graph attached to this assignment. What does the parabola resemble? That's up to you. What is the y-intercept of the graph? Okay, so let's look at the graph, right? And then let's look at our notes and see what a y-intercept is, right? Let's go to y-intercept. That touches the y-axis. The point on the quadratic function that touches the y-axis. What does that mean? That means that it's the point that touches this line, right? One of my mouse is going over, up to down, right? So where does it touch that line? Right here, right? And what's that point going to be? Okay, that was simple enough, right? Go back to classwork. And let's get on to the star connection, because that was the bulk of the work for the next week. Okay, so I already turned this one in, but let's say I wanted to start over, right? Star connection. Okay, and what is it asking us? It's asking us to answer 2, 15, 28, 34. Okay, and then it's all about star connection throughout the week, and on Friday we get to 33 and 40. So I'm just going to work all the way through those, guys. All right? Okay, so starting with 2, what is the vertex of the graph of the quadratic function f(x) equals x squared plus 6x plus 10? Okay, what's my vertex again? I think it's going up, right? A maximum or minimum point on a parabola related to the y value. Okay, so if it's curved up like that, it's going to be that point. If it's curved down like that, it's going to be that point at the top or at the bottom, whatever you prefer. Okay, so how do I know what this guy looks like? I think I got to graph it, right? So x squared plus 6x plus 10. Let's get rid of this guy. X squared plus 6x plus 10. Okay? Okay. And I think that guy looks more like this guy, right? So it's going to be that point right there. So let's click on him. Okay. I think that's probably my answer. All right, moving on. What is the solution set for the quadratic equation x squared minus 16 equals 0? All right, guys. So I know in the last video I kind of messed up on explaining solution set, right? But what we're talking about here is just x-intercepts, right? X-intercepts, roots, zeros. What are those again? Let's go back to our PowerPoint. Okay, right here. X-intercepts right here. And it's the point touches the x-axis, right? So you see this point, it's on the left to right line, right? This point also on the left to right line, right? So what was it? X squared minus 16 equals 0. So I'm just going to type that out, right? And remember how I get my x squared, guys? I have the top little arrow guy. It's shift 6, right? On your computer. So x squared minus 16. And we don't have to put in the 0, guys. We don't have to. We can, but we don't have to, right? Because we look at our points right here. This is our function, right? So the 0 that we're talking about just means that it's an x-intercept, right? We're just looking for x-intercepts when it says solution set, right? So when it crosses this left to right line, I see 2 points to do it. I see this point, and I see that point, right? Okay. Let's go on to 28. The function y equals x squared plus x minus 6 is graphed below. Okay, what about when it's negative 4? So again, look at the way this is oriented, guys, this problem. See? You see the negative 4 right here on the end? Think of that guy as a y, right? So I'm going to graph this graph on Desmos, right? And I'm going to look for y is negative 4. In other words, I'm going to go down 1, 2, 3, 4 right here. And if you want to look at this graph, we could probably figure it out. I see this point right here. I see this point right here. If you can graph, you can just count those points, right? But I don't want to count the points. I want to have Desmos just let me click on the answer, right? X squared plus x minus 6 plus x minus 6. And it said when it's negative 4, so I go down to negative 4 right here, right? Now I go across. So, okay, I see point right here. It's not going to let me click on it, right? But I got a cool trick for that. Just put y equals negative 4, like that across, and then now we can see. So I see that point, and I see that point. So it's asking us, what is x when y is negative 4, right? So I see negative 4s on the right side of both of these, right? So what I'm looking for is the number on the left side of the comma here, right? The number on the left side here, number on the left side here, right? And I think some of these answer choices should match up with that. Let's see. And by golly, I think I see it. All right. Okay, a table of values for the quadratic function f is shown below. Now pay attention to this one, guys. This is the one I messed up on the last video, but I'm not going to get it wrong this time. Okay, it says, if 3 is one solution to fx equals 0, what is the value of the other solution? Okay, so that's a trickster, guys. F of x equals 0 and 3 being a solution has nothing to do with the other solution, right? They're just trying to trick you, right? All I want y'all to look for, because it says fx equals 0, right? So I'm just going to look for a 0 on this f of x column, right? And I think I see it right here, right? And what is the x number to the left? I think that'll be my answer, right? Okay, 2 points on the graph of a quadratic function are shown on the grid below. 2 points on the graph. What is the equation for the axis of symmetry of the graph below? Well, we go from, let's see, 1, 2, 3, 4, 5, 6, right? I went 6 this way, so you have 6 across, right? So whenever I have an axis of symmetry, guys, I'm trying to split it in half, right? So if I'm going 6 to the left here, what's 6 divided by 2? 6 divided by 2 is 3, right? So I go 1, 2, 3 over. What's that x value right there? So it's going to be x equals this value right there in between 0 and negative 6. All right? Ooh, getting more difficult.